Hey guys, so this is going to be a video on calculating a stoichiometry chart using molarity, and we're also going to do some limiting reagent stuff, so it's kind of going to be like a twofer. But what I want you guys to do right now is pause the video and read the question and then try to just write the balanced equation and see if you can get that far. So do that now. Okay, hopefully you pause the video, and here's the balanced equation. So I got the K2CO3 plus MgCl2. It gave me one of the products, which is magnesium carbonate, and it didn't talk about any other products, but I know there has to be one because it's a double replacement reaction. And so the KCl is just what was left over. So pause the video again and then try to do our starting steps. Remember, we have to identify the two main things. Where do we start and what do we want? And then I'll draw your charts. And don't forget that the volume has to be in liters. So convert your milliliters to liters. Remember, you just got to move the decimal to the left 3 times. And then also rewrite molarity as an equality. In other words, rewrite molarity as a fraction. So pause the video, see if you can do all that, or at least get as far as you can, and then go ahead and press play and see how you did. Okay, so here is what here's what I've got so far. So I looked at the question, I identified my 2 starting points, which is the purple and the blue, and I did rewrite my milliliters as liters, and so that's why. Oh, that shouldn't be blue. That should be purple. Sorry. Anyway, just cross that out. So I have my liters and I have my liters. And then I also rewrote molarity. Remember, capital M molarity equals moles per liter. So we can rewrite that, as the fraction. So instead of 0.5 capital M, we write 0.5 moles, MOL, over 1 liter. Now I want you to just look here. I put AQ here, and just as a little side note, remember that aqueous means dissolved in water. And in our notes, it says that this should be 1 liter of solution. So you might be asking yourself, well, why did she put MgCl2 when it's supposed to be solution? Well, remember that if it's aqueous, it means that it's a magnesium chloride solution, where the magnesium chloride is the solute and the water is the solvent. So when we write MgCl2, it's kind of implied that the numerator is the solid dissolved into the solution, which is on the denominator. So I just wanted to point that out real quick. Okay, so then I started my charts, and that's where I'm at so far. So hopefully you guys were able to get to this point. This is all like old stuff. So find which part you struggled with and go and rewatch those videos, because this is really going to focus on just the molarity and the limiting reagent parts of this. All right, so I'm going to start my first chart here with the purple one. I know I have liters of K2CO3, so I'm definitely going to have liters of K2CO3 down here. I already knew that I was going to have 3 extra steps after my first step. Why? Because I know that I always go from what's given to moles, cross the mole bridge, and go to what the question wants. So without even looking at the details of the question, I can fill in all of my units. For example, I know this is liters, and I'm going to go to moles. That's always, my main goal is to go to moles. So I'm going to have moles of K2CO3. Then if that's there, then I'm going to have moles of K2CO3 on the bottom, because that's what I started with. Up top goes what we want, and that's going to be moles of MgCO3. And then, of course, if that's up there, then moles of MgCO3 is going to be on the bottom. And the question wants grams of solid product. So I'm going to have grams of MgCO3 up there. So really, just by looking at the units and how the chart is set up, I have like more than half the work done already. And now you just got to figure out what the numbers are. So let's start with this first part here. I have moles over liters. Normally, you would be inclined to put 22.4 here, but we cannot do that because we have a molarity given. If you're given a molarity, you're probably going to use it. So let's use it right here. I have 0.5 moles over 1 liter. So I'm just going to plug that in, 0.5. Oops, I'm in the wrong color. what color am I at? Purple. So 0.5 moles for every 1 liter, if you want to put a 0 in there for sig figs. And then this is our mole bridge. So think to yourself, where do we get the mole bridge from? Hopefully you're saying coefficients in the balanced equation. So there's going to be a 1 here. And then on top, the coefficient of MgCO3, he's also a 1. We have moles and grams. Grams always has 1 mole. And then if you look up the mass of Mg plus carbon plus 3 oxygens, you should get 84.32. So take a look at that and make sure you understand where all the numbers came from. And while I calculate this here, see if you can fill out the bottom chart before I do it. So I'm just gonna plug this in my calculator. Okay, so I got for my first answer, and hopefully, you should be able to put this in your calculator as well. But when you do that, you should get 1.054 grams of MgCO3. All right, now hopefully when you started the second chart, you saw right away 2 charts. Ending has to be the same. So everything in orange is going to match. So I'm going to have 1 mole of MgCO3 and 84.32 grams of MgCO3, and then 1 mole on the bottom. So now I just got to figure out my blue liters here. So I'm going to put liters MgCl2. It is a solution, so I'm going to go back up to my molarity. And this right here is my molarity of the magnesium chloride solution. So I'm going to have 0.30 moles for every 1 liter. And then I look for my coefficient. Magnesium chloride is right there. So 1 mole MgCl2. And then we'll plug that in the calculator. 0.015 times 0.3. The 1/1 is just 1, and then times 84.32. Oh, excuse me. And I get 0.379 grams of MgCO3. Okay, so now here's where a lot of you have been struggling. You can do all the hard parts, but because of the vocabulary, you're struggling with identifying the answer. So, grams of solid product, and then you're struggling with limiting reactants. So let's do that real quick. So we know that when we have 2 charts, we're going to get 2 answers, but only one of them is correct. We can only make as much as the limiting reagent allows. We can only make as much as, the products that we're given can produce. So if I'm looking at 1.054 and 0.37, well, if this is the smallest amount I can make, then I don't have enough to make this. So this right here is going to be my final answer. That's how many grams of product are produced. So that's right there. And then the second question is, what is your limiting reagent? So remember, by definition, limiting reagent is the reactant that yielded the least amount of product, or the limiting reactant that made the theoretical yield, or the limiting reactant that made the lowest amount of product. However you want to word that. There's like 1,700 different ways to word it. But basically, you want to know who made this amount of product. This is product, right? He's over on the right side of the arrow. The limiting reagent is a reactant. So it's either going to be this guy or it's going to be this guy, magnesium chloride or potassium carbonate. So who made magnesium carbonate? Boo, 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 boo. Oh, it was magnesium chloride. So he is the winner. He is my limiting reagent. And there you have it. Feel free to go back, rewatch. Let me know what questions you have, and hopefully you will be good to go. Thanks.